All right, hello everybody. Today we're going to go over balancing equations worksheet. Remember, we can think of the arrow like an equal sign. We have our reactant and our products in our chemical equation. And now what we're going to do is we're going to count up to just make sure. So on this side, we have aluminum. We only have one. And we have oxygen, and we have two right now because the subscript denotes that there's two. On the product side, we have two aluminums and three oxygen. Well, obviously, the first thing we need to make the oxygen's balance, or sorry, the aluminum's balance, and that would create a 2 in front of this aluminum, and that would give us 2. That would be balanced now, but our oxygen still aren't quite right. So if we take, maybe the least common multiple of 2 and 3, which would be 6, and we multiplied 2 by 3, which gave us 6, and we multiplied this whole thing by 2, that would give us 6 oxygen because 2 times 3 is 6. All right, the problem though is that now gives us 2 times 2, 4 aluminum. Now, instead of 2 aluminum, we need to put the coefficient 4 in front of it. And now we have 4. So 4 and 4, that works out. 6 and 6, that works out. And our equation is 4 aluminum plus 3 O2 gives us 2 aluminum Al2O3s. Write that a little bit better. Okay, so that's our answer for number 1. Number 2, again, we'll start by remembering that this is like an equal sign. We have our reactants on the left, our products on the right, and we'll start with mercury, Hg. We have 1, or sorry, we have 2 on this side, or never mind, we have 1, excuse me, and oxygen, we have 1. If we go to the right side, starting here with that one, we have 1 mercury and 2 oxygen. So obviously we need to increase the amount of oxygen on the left side. So if we put a 2 in front of that, that gives us 2 oxygen and 2 mercury. And now the only problem is this guy. And the way we fix that, is if we put a 2 in front of there. Now we have 2 everywhere that we need it, so that we have 2 mercury on this side, we have 2 mercury on this side, we have 2 oxygen over here, we have 2 oxygen over here. All right, they cancel out, we're all good, and our new equation is 2HgO gives us 2Hg plus O2. Number 3, now we're getting into some bigger ones. So again, we didn't do that. We have our reactants and our products. So our products are over here. Reactants are over here. All right, and not getting annoyed at all. We can set up our little line. So sodium, oxygen, hydrogen, sulfur. Those are the 4 elements that are on either side. On the left side right away, we have 1 sodium, we have 4 plus 1, we have 5 oxygen, we have 1, 2, 3 hydrogen, and 1 sulfur. On this side, we have 2 sodium, 1 sulfur, 4 plus 1 is 5 oxygen, and 2 hydrogen right there. So obviously that's not quite right. The easiest way to start this one is to take the biggest one that's a little bit goofed up, which is going to be this piece right here, and we're going to double the sodium. So if we put a 2 in front of there, now we have doubled this amount of sodium. going to put that in red. All right, but we have also given us 6 oxygen by doing that, so by making this 2, and we've also given us 4 hydrogen. So the sodiums are good. Now we need to increase 1 oxygen and 2 hydrogen on this side. Well, the really easy way to do that, if you put a 2 there in front of the H2O, our 2 distributed to the H2 now becomes 4 hydrogen. And distributed there, we have 4 plus 2, which is 6. And now we have a equation where sodium, oxygen, hydrogen, and sulfur are all balanced. And our new equation, 2 NaOH plus H2SO4 gives us Na2SO4 plus 2H2O. All right, and that's our answer. Moving on to the next one, we have iron oxide. So we have Fe, which is iron, and oxygen in this equation. We have our equals, or our arrow, which is like our equal sign, with our products on the right, reactants on the left. We have 2 elements. We have iron and we have oxygen. On the left, we have 1 iron, 2 oxygen. On the right, we have 2 iron, 3 oxygen. The first thing I would do is let's get the oxygens equal. So we have 3 and 2. The easiest way is to find the least common multiple, which is going to be 6. So we want 6 on each side. So how do we get 2 to 6? Well, we multiply both things by 3. If we multiply 2 by 3, we get 6. So if we put a 3 there, now we have 6. How do we get this here, this 3 to a 6? Multiply it by 2, right? Distributes, we get 6, which is all good. But now we have, because we have to distribute it to that iron 2, now we have 4 irons as well. All right, the easiest way to go from 1 iron here, put a 4 in front of it, distribute. 4 times 1 is 4. So by putting a 4 in front, now we have 4 irons. The irons cancel out, the oxygens cancel out. We have equal masses. And our equation is 4Fe plus 3O2 gives us 2Fe2O3s. Last one for this side. All right, we got big ones here with lead. So we can, again, remember we have our products and our reactants. So our products are over here. Reactants are over here. And we can start, we have lead, nitrogen, oxygen, potassium, chromium on either side. So when we get a 2 like that, we're going to distribute to both atoms inside the parentheses, just like you would in math. So we have 1 lead, 2 nitrogen, 6 oxygen here, so 6, and then 4. That gives us 10 total. And 2 potassium right there, and 1 chromium. On the other side, 1 lead, 1 chromium, 4 oxygen there, 3 there for a total of 7. 1 potassium, 1 nitrogen. Now this one might look really big and scary, but this one's actually pretty simple. We know that we need to change the oxygen and the potassium and the nitrogen. Well, which element on the product side has all 3? Right there. So if we actually just put a 2 in front, now we're distributing that 2 to each one of those. We now bump our First one, 2 times 1 on the potassium gives us 2 potassium. Great, that cancels out. If we distribute that 2 to the nitrogen, 2 times 1 is 2. And now we have 2 nitrogen, which is now good. And oh my goodness, 2 times 3 is equal to 6. So we have 6 oxygen over here. 6 plus 4 equals 10. And if we look at it, lead's all good, nitrogen's good, oxygen is good now, potassium and chromium are all good now. And our new equation is P, oops, that's ugly. What is going on? What the heck is going on? Sorry about that. Our new equation is PbNO3 2 plus K2CO4 gives us, so we didn't even change anything on the reactant side, we only changed the products. We get PbCrO4 plus, I'm sorry, I'm writing down below, but we're running out of room, 2KNO3. So really the only thing that we changed in this whole problem was this piece right there. All right, on to the next page. And guys and girls, I hope you're watching this because these things are on your test tomorrow, which is our last test, the last chance to improve your grade. Number 6, pretty easy one. We have a simple equation with our products and our reactants. We have hydrogen and we have nitrogen. On the left side, we have 2 hydrogen and 2 nitrogen, so 2 and 2. On the right side, we have 1 nitrogen and 3 hydrogen. So the easiest thing right away is to find the least common multiple of that 3 and the 2, which is going to be 6. So to multiply 2 to equal 6, we got to multiply this whole thing by 3. So we'll multiply this thing by 3. That gives us 2 times 3 is 6. Multiply this whole thing by 2. That gives us 6 there as well, which is great. But now the problem is we got 2 nitrogen. Is that a problem? No, because they all cancel out now. Everything works. Everything's happy. We're good. So our final equation is 3H2 plus N2 gives us 2NH3. And that's your equation. Next one, a little bit bigger. We have copper plus NaO3 gives us copper NaO3 to the second times NO3, excuse me, times Na. So let's start with our elements. So we have copper on the left, sodium on the left, nitrogen and oxygen. We have 1 copper on the left, 1 sodium, 1 nitrogen, 3 oxygen on the right side. We have 1 copper, we have 1 sodium, we have, because this distributes to both things in parentheses, we have 2 nitrogen and 6 oxygen. All right, well, this seems like it'd be a pretty easy fix, right? The first thing, let's see what we can do on this side to get that oxygen number from 3 to 6. The easiest one, multiply it by 2. Right, so if we multiply this by 2, we multiply everything in there by 2. Na times 2 is 2. Nitrogen times 2 is 2, and O3 times 2 is 6. Hey, that's all good. Now the only problem is because now we've already solved our nitrogen, we solved our oxygen, the copper's good. The only one left is this guy right here, the sodium. How can we make one Na into two NAs? Let's put a coefficient of 2 in front of it. And our answer is then, that balances, and our answer is copper plus 2NaNO3 gives us copper, nitrogen 3, and I'm sorry, again, I got to move down, 2Na. And that's our answer. You really shouldn't be moving down like that, but I was just running out of space, and I don't think it writes outside of the white page. So try and keep it on one line if possible. All right, couple more to go. The next one we have is iron copper chloride equals iron chloride plus copper. So again, think about that arrow like an equal sign. We have our products on the right, reactants on the left. And we start with iron, copper, chlorine. We have one iron on the left, one copper on the left, two chlorine. We have one iron on the left, one copper, two chlorine. This looks kind of tricky, doesn't it? Do we need to change anything? No, everything's good. So you can just rewrite this equation. This one's kind of in there to throw you off. This is a balanced equation right from the beginning. Good. All right, two more to go. Though. Let's hope they're as easy as those ones, right? Here's our reactants. We have potassium chloride with some oxygen, chlorate. I can't remember what the exact name for that compound is. And we have our products over here. So we have potassium, chlorine, and oxygen. We have 1, 1, and 3 on the left side. Over here we have one potassium, one chlorine, and 2 oxygen. All right, the first thing we got to do, least common multiple between 2 and 3 is 6. Let's start here on the right side. So we're going to start right here. 2 times what equals 6? 3. And that gives us now 6. Now the only problem is we got to multiply this whole thing by 2 because that gives us 6 here. The only problem then is that now it gives us 2 potassium, 2 chlorine. Well, that's a pretty easy fix, right? Because all we have to do is multiply that whole molecule by 2, so we distribute that 2 to both sides. And now everything's got 2 or 6, everything's balanced, and our equation reads 2 KClO3 gives us 2 potassium chlorine plus 3O2. All right, almost done. One more. Our last question, Mg plus HCl gives us 2H2 plus MgCl2. Again, think of that as an equal sign. We got our little line. We have our reactants. We have our products on the left side. We have magnesium, hydrogen, and chlorine. We have one magnesium, one hydrogen, one chlorine on the left. We have 2 hydrogen, 1 magnesium, 2 chlorine on this side. Now, the easiest way about this, all we got to do is change the hydrogen and the chlorine. And guess what? We have now a molecule that only has those 2 in it. So that now gives us 2 hydrogen because you distribute that 2 to there, and 2 chlorine, and we're all good. So our new equation, our balanced equation is Mg plus 2HCl gives us H2 plus MgCl2. All right, that's your whole assignment. Go back and look at all the problems. You'll see these again on your test tomorrow. Good luck. Let me know if you have any